Chapter 13, one of the topics is dimensional analysis. In dimensional analysis, you're going to use something called a conversion factor, which is a fraction equivalent to 1, but the numerator and denominator are made up of different numbers. I'm going to show you a couple of examples of using conversion factors. First problem comes from page 682 in your text, and it's problem number 3, and we're going to look at parts A and B. Part A says, how many inches in a mile? Well, we know, for example, that in 1 mile there are 5,280 feet. So we can make a conversion factor 1 mile over 5,280 feet, or 5,280 feet over 1 mile. We're going to start with the 1 mile, and we want to convert 2 feet, so we're going to put 5,280 feet over 1 mile. Now you notice when we multiply these fractions, the miles units will cancel out and we're left with feet. A second conversion factor, and this is pretty common knowledge, 12 inches in 1 foot. We're going to have miles canceling out, feet canceling out, and our answer will be the number of inches that are in 1 mile. We simply multiply 5,280 times 12, and that result is 63,360, and that's inches in 1 mile. Now, the second problem we're going to look at, how many square yards in 43,560 square feet? First off, let's say you have a square that is 1 yard by 1 yard. That's 1 square yard. But in a yard there are 3 feet. So it's also 3 feet by 3 feet. So in 1 square yard, we have 3 feet times 3 feet, which is 9 square feet. So 1 square yard is 9 square feet. Now, let's make a conversion factor to change this number to square yards. We have 43,560 square feet. And I'm going to put it over 1. Multiply that by 1 square yard over 9 square feet. Notice that the square feet units cancel out, and it's actually 43,560 divided by 9 for our final answer, and that comes out to 4,840 square yards. The next problem we're going to look at is using a formula to change one temperature scale to another temperature, and this is problem number 16. Part B we'll look at. Change 60 degrees Fahrenheit to Celsius. The formula for change is C, Celsius temperature, is equal to F minus 32 divided by 1.8. So this formula is quite easy to use. We simply plug in or substitute 60 degrees for the F, subtract 32, divide that result by 1.8. That's 28 over 1.8, and this is approximately 15.6 degrees. We could say 16 degrees if we wanted to round off. The second problem is on page 703, and the second section gets into some area formulas. We're looking at areas and perimeters of some basic geometric shapes. We have here a triangle. The sides of the triangle are 42.7, 65.3, and 87.6. This is problem 11 on page 703. Now, this number represents the height of the triangle. That's 39.6, and we know it's the height because it's perpendicular to the ground or the base. First, the perimeter is simply the sum of the lengths of the sides. 42.7 plus 65.3 plus 87.6. Just add them together. And that perimeter is 195.6. If the unit is feet, perimeter is in feet. If the unit is inches, perimeter is in inches. It's the same dimensional unit. Area for a triangle, the formula is 1/2 times the base times the height. The base length for our triangle is 65.3. The height is 39.6. So we're going to substitute 1/2 times 65.3 times 39.6. Now we can multiply these two and then divide by 2. The result is 1,292.94. Now, here's a difference. Let's say that our unit of measure for the triangle is in inches. The area is square inches. It's always a square unit. We're going to look at a very important property in mathematics. It's called the triangle inequality. It's important enough to have its own name. Triangle inequality basically says this: if you have three numbers that represent the sides of a triangle, the sum of any two has to be more than the third side. And that has to be true for any order that you take the sides in. On page 704, problem number 2, three sides of a triangle are given, and this is problem 2A. Three sides. X is one side, it's the square root of 50. Y is 3.47, and Z is 4.28. Could these be the sides of a triangle? Well, we have to approximate the square root of 50, and you can verify with your calculator that that's approximately 7.07. Now, here's how the triangle inequality works. If these are our three sides, then x plus y has to be more than z. X plus z has to be more than y. And y plus z has to be more than x. All three of these must be true. Well, let's see if that is the case. 7.07 plus 3.47, well, that's more than 10, so that's obviously more than 4.28, so that one's true. 7.07 plus 4.28, and that's obviously more than 11, that's more than 3.47, and that's true. The third one, 3.47 plus 4.28, I'll actually add those two together. 3.47, let's see, that's 5, 7, That's 7.75, and that is more than 7.07, and that's true. It is a triangle. If any one of those had been false, we would not have a triangle.